Right, we're going to recap some basic angle facts for you. So here we've got a diagram with some straight edges and straight lines in, meeting at various vertices with angles labelled. Often in exam questions and questions in textbook, they are labelled in the most helpful order. So angle A should be done before angle B, C, D and E. Clearly in the real world, problems aren't given to you with answers provided, so that's just a useful thing for textbooks. So this should cover all the things you ought to know from earlier in school to attack this new unit. First things first, angle A is at this vertex here, and these three angles are all around a point. There's no circle here, so anybody who thinks this angle's in a circle needs to just forget that. It's a point which they are around. There's a symbol here which tells you this angle is actually 90 degrees, so clearly this isn't drawn to scale, and you should never assume anything's drawn to scale in a question. So angles around a point add up to something. They add up to 360 degrees. The add up to is important there. It's not that they are 360 degrees, it's that they add up to. So to work out A, you would need to do A equals 360 degrees, take away whatever else is there. In this case it's 90 degrees plus 202 degrees. And there's no harm in putting that through a calculator just to make sure you get it correct. Don't forget the bracket. And that is 68 degrees. And it's important here for full marks in any exam and full reasoning you write down what you did. So here the rule was angles around a point sum to 360 degrees. Sum being another word for add up to or total. So you can use add up to or you can use sum to. So having worked out A, I'm going to label it in here just so I don't forget. And then work around for B. Now B is attached to a lot of things, and part of the skill of this is picking what's the most useful. And in fact B best is described as being inside this quadrilateral. So there are 4 angles here inside this quadrilateral, and you should know that 4 angles in a quadrilateral also add up to 360 degrees. So B is 360 degrees, take away the ones that we know in the quadrilateral, and they're these 3 here. So that's 68 plus 134 plus 157. And why would you guess when you have a calculator? Apparently that's 1 degree, so this really isn't to scale. Have I typed that correctly? Yep, I've just clearly got a silly scale. And that was, again, the rule needs to be written in a quadrilateral sum to 360 degrees. Okay, that's A and B done. C is up here. Actually, C is to do with this cross. This cross here happens at a vertex, and these 2 angles are opposite each other at the vertex. They are vertically opposite a vertex. And that means they're just the same. So C is 68 degrees, and the rule was vertically opposite angles are equal. So I've got a 1 degree in here and I've got a 68 degrees in here. Alright, so we're writing a calculation where 1 is required, and we're not when it's just the same, and we're always writing a rule to make sure we get full marks on any question. Right, angle D. Again, it's in lots of places. Part of the skill is picking out what it's best, so if we can ignore all of this, and we can ignore this, and we're left with a triangle, which means that D is in that triangle, and angles in a triangle do something. They add up to 180 degrees. That's 180, take away whatever we're given, which in this case is 68 and 35 degrees. And that's 77 degrees. I don't know whether that's coming up on the screen or not. It looks pretty clear. Right, and that means, and the angle rule we used there was angles in a triangle add up to 180 degrees. So that's going to be important for the rest of this topic, this rule about triangles, and you might spot something about the quadrilateral and the triangle, maybe, which we'll draw on next lesson, next video. Finally, E, again, the trick is to remember which things to ignore, work out what things you don't need. Well, if we just cover all that up, and we cover all the triangle up, we have got E just sitting on a line next to D. Now, angles on a line seems to be one that a lot of people get wrong. It's only at this point, so the line is at a point on a line. These angles over here are on the same line. They're not part of this rule, because they're not at this vertex. These aren't part of it either, so it's just this region here where they all meet on a line. And angles on a line add up to 180 degrees, so finally E is 180 degrees, take away 77 degrees, which is 103, I reckon, 103. And that is angles on a line sum to 180 degrees. Now, no doubt some of you will be shouting out about exterior angles at this point if you've seen something about triangles before. Don't worry, we will cover that. But you might want to think about how these are both 180, take away something, and the same angle appears here and here. There's going to be some symmetry here you might want to play with, but that's not essential for this unit. It's making sure that you actually write all of your working out and all of your rules like this. So a thing that looks big and scary like this has got lots of little bits, each of which are fairly straightforward, and each of which on their own is a straightforward thing. It's just that there are a lot of them in a row. See you next time for the trickier stuff.